As one studies the branching of the family tree of theropod dinosaurs, one notices that the adaptations which birds would use in flight evolved slowly at gradual points in this family tree. The group of theropod dinosaurs which is closest to the branch which would lead to the first birds is named Par aves. And one of the members of this Par aves group of theropod dinosaurs was a small theropod named Microraptor. Starting with specimens discovered in the year 2000, the genus Microraptor has produced hundreds of specimens, which some divide into three separate species. Others feel that perhaps one variable species best describes this collection of fossils. Either way, they are small theropods, and some were, at the time of their discovery, the smallest theropods known, the smallest being able to fit in the palm of your hand if the tail could then curl outside of your hand. So an average size might be about a kilogram or 2 pounds, and 80 centimeters long. They are known from China from the early Cretaceous period about 120 million years ago. It is obviously of interest that dinosaurs possessed feather-like structures in their integument. A number of dinosaurs are known to have had the equivalent of downy-like feathers or proto-feathers covering them, perhaps to keep warm. But then some dinosaurs actually possessed the type of contour feathers which are used for flight in birds. Many of these would have been incapable of flight, just too big and too heavy, but nevertheless they possessed flight feathers, which might have been used for display or courtship or something. But Microraptor was small enough that its feathers might actually allow for gliding or some type of flight. Obviously, it is of interest that in addition to having flight feathers on its arms and tail, as other dinosaurs did, there were also flight feathers on its legs, calling some to want to name the dinosaur Tetrateryx, or four-wing. These feathers and the elongated arms and the light build would have allowed Microraptor to glide, certainly, but according to a number of studies which have considered the aerodynamics of its build, at least some degree of powered flight. There were adaptations of the body which seemed to favor flight, such as elongated arms, fused bones in the sternum, the flight feathers obviously, but also these feathers were asymmetrical. Asymmetrical feathers have a structure which is adapted for flight. And the fact that not only were there asymmetrical feathers, but also asymmetrical feathers on the legs indicates that natural selection was favoring a feather structure for flight. And so Microraptor was certainly capable of gliding and perhaps even of powered flight. And so the skies of the Cretaceous not only contained early birds capable of flight, but also then at least some theropod dinosaurs capable of some degree of flight. In one specimen of Microraptor, the soft tissues were preserved well enough that the color of the feathers could be studied, and it was determined that they were black in color, but an iridescent black in color. It is wonderful that so many specimens of Microraptor have been discovered, several hundred, and a few have actually preserved their stomach contents. One had the remains of a small mammal in its gut, one a small lizard, one the type of bird which was most common during the Cretaceous period, the opposite birds or enantiornithine birds, and one had remains of fish in its gut. And so these several specimens give evidence that Microraptor was a predator which had quite a varied diet and was capable of capturing diverse types of prey.